All right, good morning, everyone. So here is my second video, and it's specifically and exclusively on graphing the tangent function. So the tangent function is different than the previous two, the sine and the cosine, because it is not continuous, it is discontinuous. So that's what makes it different from the other two. So again, in this video, what I'm showing you, and that's alluded to in the other videos, is how to graph the parent graph of the tangent function. And again, just like in the previous video, I'm using the four quadrantial angles: 0, pi over 2, pi, 3 pi over 2, and then 2 pi. So I'm going around one full revolution of the unit circle. As you can see here, the ordered pair that goes with each of these angles. So 0, it's 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And 2 pi, it's the same ordered pair as 0 because you're at the same point. So I want to go over the values of these angles for tangent to make sure you're clear on how to graph this, and then you'll see specifically why it's discontinuous. So remember, the tangent of angle is y over x, or sine over cosine. So for example, if I'm right here, the tangent of 0, 0 over 1, that is 0. Does that go counterclockwise to pi over 2? The tangent, look at this, sine over cosine, that's 1 over 0. You can't divide by 0, so that's undefined. And this concept right here is what makes the tangent graph discontinuous. Continue on at pi, y over x, you end up with 0. And then 3 pi over 2, your y divided by x, that is also undefined. And then tangent of 2 pi is the same as the tangent of 0. That would be 0. That means you're returning all the way back here. Right? So I want to take this information and now graph this. Now also, when I go to graph this, I'm going to go use these angles here, this way, going in the positive direction, as well as I'm going to go this way to use the negative angles. So remember, when I go this way, this would be negative pi over 2. So the tangent of negative pi over 2 has the same value as 3 pi over 2. Then it'd be at negative pi. This would be negative 3 pi over 2. And then this would be negative 2 pi. So let's take this information and now graph. So right here, I'm going to graph the parent graph, the foundation graph of y equals tangent of x over a couple of periods. Okay. Now, as you start at 0 and look to the right, so the tangent of 0 is 0, notice that the tangent of pi over 2 is undefined. How you graph something that is undefined is you put a vertical dotted line, which means that no part of the graph is ever going to touch this angle right here at all. And then we continue on, tangent of pi is 0, and then tangent of 3 pi over 2 is undefined. That's why I have a vertical dotted line, and tangent of 2 pi is 0, the same as this. And like I showed you, going in the negative direction here, tangent of negative pi over 2, it's the same as tangent of 3 pi over 2, undefined, so I have a vertical dotted line. Tangent of negative pi is 0. And tangent of negative 3 pi over 2 is the same as tangent of pi over 2. So I have a vertical dotted line here. The negative 2 pi, the tangent of that is also 0. Now what I'm going to be able to do here is I'm actually going to be able to graph 3 periods. So what I'm going to do is I'm going to show you what the graph looks like between these vertical asymptotes. I can say the graph, or I can also say the branch of the tangent function. So what it does, it looks like this. So you left to right, it's going to move like this. So these vertical asymptotes act as boundaries for each branch of the tangent function. So it's never going to intersect or cross a vertical asymptote. And it looks the same as I go to the right. Each branch is going to look the same, like this, and then like this. Okay. Now, for the sine and cosine functions, I talked about amplitude. You can see here as you look at each branch, the tangent function continues to go up forever and ever, or towards positive infinity, and then towards negative infinity. So there's no exact amplitude here. Now, the length of one period, though, it's different than sine or cosine. Okay, so if you look at the distance here, from 3 pi over 2 to negative pi over 2, that is pi. And that is consistent with the other ones, the other vertical asymptotes between here and here. The distance is pi, and from here to here, it's pi also. So both directions moving to the right and to the left, this is how the tangent graph is going to look. Each branch is going to look like this in between your vertical asymptotes. So that is your discontinuous graph of the tangent function. So what's going to happen next here, as you understand these foundation graphs, you're then going to learn how to graph the sine, cosine, and tangent graphs with different types of transformations. So you have to understand these parent graphs first before you can understand how to transform them. All right, I hope you guys are doing well, and have a great day, and I will talk to you later.